Look up on a clear night, and you might spot a bright, steady light racing across the sky. That's the International Space Station, or ISS. For over 2 decades, the ISS has been humanity's outpost in space, a symbol of what we can achieve together. This massive orbiting laboratory is made up of interconnected modules, solar arrays, and robotic arms, all assembled in the vacuum of space. Circling Earth every 90 minutes, it's the largest structure humans have ever built in orbit. The ISS is a partnership between the United States, Russia, Europe, Japan, and Canada, a beacon of international cooperation. Astronauts from rival nations become crewmates, sharing meals, experiments, and a unique view of our fragile planet. The station's main mission: research that can't be done on Earth, from studying microgravity's effects on the human body to testing new materials and technologies. This knowledge is vital for future missions to Mars and beyond. The ISS is a self-contained world, recycling air and water, shielding its crew from radiation and extreme temperatures. Astronauts live and work here for months, maintaining the station and conducting experiments for scientists back home. It's more than a machine, it's a human story, written in the stars. The ISS stands as a testament to unity, exploration, and the shared dream of reaching beyond our world. The ISS is a unique laboratory where gravity's grip is nearly gone, revealing the universe in new ways. Scientists have studied how flames burn in space, how bones and muscles weaken, and how fluids shift in the body, insights that help both astronauts and patients on Earth. The station's vantage point lets astronauts monitor hurricanes, deforestation, and melting glaciers, providing crucial data for climate science. Thousands of experiments have been run, each one a piece of the puzzle of nature's laws. The ISS is a bridge between space exploration and human health, inspiring new treatments and technologies. It's also a testbed for recycling systems, spacewalks, and life support, skills we'll need for Mars. The lessons learned here are the foundation for all future journeys beyond Earth. The ISS has shown us how to live and work in space, preparing us for the next leap. Its legacy is not just scientific, it's a blueprint for international cooperation and discovery. The ISS is Earth science from the ultimate high ground. Even the greatest machines have limits. After decades in orbit, the ISS is showing its age. Constant exposure to micrometeoroids, debris, and extreme temperatures causes wear and tear, cracks, leaks, and metal fatigue. Maintenance costs are soaring, with billions spent each year just to keep the station running. As systems age, the risk of serious failure grows, making safety a top concern. NASA and its partners know it's safer to plan a controlled retirement than risk a catastrophic accident. By 2030, the ISS will be guided to a fiery re-entry, with debris targeted to fall harmlessly into the remote Pacific. This bittersweet farewell isn't the end of our presence in space, it's the start of a new era. The funds and focus freed up will drive new missions, returning to the Moon, reaching for Mars, and building the next generation of space habitats. The ISS's retirement marks a transition from government-run outposts to a future shaped by commercial innovation. It's a necessary step to keep pushing the boundaries of exploration. The story of the ISS is one of achievement, but also of knowing when to pass the torch. Its end is the beginning of something even greater. The next chapter in space is about to begin. As the ISS era ends, a bold vision emerges: commercial space cities. These aren't cities with streets and skyscrapers, but next-generation stations, privately owned, designed for research, manufacturing, and even tourism. Unlike the ISS, these outposts will be modular and expandable, growing as demand increases. They'll host scientists, private astronauts, and tourists, with labs, factories, and habitats all in orbit. The goal: a permanent self-sustaining human presence in space, moving from exploration to true settlement. Space cities will be living, evolving structures, business parks, hotels, and research hubs all in one. This shift opens space to more people and possibilities than ever before. The ISS proved we can live in space. These cities will show us how to thrive there. The race to build ISS successors is on, led by private companies partnering with NASA. Axiom Space plans to attach modules to the ISS, then detach them to form a new commercial station when the ISS retires. Blue Origin's Orbital Reef aims to be a mixed-use business park in space, with science labs, manufacturing, and adventure travel. NanoRacks, Voyager Space, and Lockheed Martin are developing Starlab, a science park with a large inflatable habitat and robotic arm. These stations are designed to be flexible, scalable, and open to a range of customers. NASA's role is shifting. Instead of building stations, it will buy services from these private outposts, freeing resources for deep space exploration. This public-private partnership is creating a competitive, sustainable economy in low Earth orbit. The transition ensures there's no gap in human presence in space. These companies aren't just building hardware, they're building the future marketplace of space. The next era of orbital living is already taking shape. Imagine waking up to the curve of Earth outside your window in a space city. Your day starts with a microgravity hygiene routine, then breakfast, maybe with fresh greens from a hydroponic garden. Work fills most of the day. Scientists run experiments, engineers maintain systems, and manufacturers oversee 3D printers making things impossible on Earth. Exercise is essential, 2 hours daily to stay healthy and weightlessness. Downtime might mean video calls home, watching sunrises from the observation cupola, or playing zero-G sports. Space cities will offer more privacy, better food, and more recreation than the ISS, supporting both body and mind. Life is a balance of work, exercise, and personal time, all while floating above the world. It's a life of purpose, helping build a new chapter of human civilization. Building space cities is a monumental challenge. Launching supplies is costly, so we must learn to use resources found in space to reduce dependence on Earth. Space is dangerous. Radiation, micrometeoroids, and debris threaten both people and hardware. Advanced shielding and tracking systems are essential for safety. The business case is unproven. Will enough customers pay for research, manufacturing, and tourism to sustain these stations? Governments will be anchor tenants, but private demand must grow for true sustainability. Living in space is tough. Bone loss, muscle atrophy, and psychological stress are real hurdles. We need better countermeasures and supportive environments for long-term crews. The human factor is the most complex challenge of all. Overcoming these obstacles is key to making space cities a reality. Despite the challenges, space cities hold immense promise. Microgravity could unlock breakthroughs in medicine and materials, improving life on Earth in ways we can't yet imagine. These outposts are our first steps toward becoming a multi-planetary species, a form of cosmic insurance for humanity. The skills and technologies developed here will pave the way for settlements on the Moon and Mars. The view from orbit, the overview effect, can inspire unity and a sense of shared responsibility for our planet. Space cities could create new jobs, industries, and even clean energy solutions for Earth. The dream is to make space part of our economic sphere, solving big challenges back home. These cities are the foundation for a future unbound by gravity. Our potential is no longer limited to Earth. The story of space exploration is about looking forward. The ISS taught us how to live in space, but now it's time to build a vibrant ecosystem of commercial space cities. This transition is essential for a permanent, sustainable future beyond Earth. The innovations needed for space cities, recycling, robotics, energy, will transform life on Earth. The next steps are already underway. Companies are building, NASA is funding, and a new generation is training for missions. The coming decade will see the birth of a true spacefaring economy. The journey from the ISS to space cities is more than engineering. It's about our desire to explore and expand human experience. We must keep looking up, dreaming and working together to build our future among the stars. The journey is just beginning. The sky is not the limit, it's the invitation.